Alright guys, so let us get started with one of our new function, and this is going to be an important one. Just because this function will be relating the concept that we were referring to in the previous section, and that was regarding the data modeling, right? So in the previous section itself, we were referring that how exactly we can connect these dimension tables, all of these tables up above our fact table. So how exactly we can build a relationship among these tables that we were referring to in the last video, right? So you might be aware about these things, but at this point, that what exactly this one symbol signifies over here, what exactly this many symbol is showing over here, right? So by making the use of this similar concept itself, we are going to come up with a new function that will be helping us out to make the use of a column that is already there in our dimension table, and that column I can simply extract out as a new column in my fact table, and that function is going to be the related function. So first of all, let me show you the syntax for the related function. So this related function will be having a parameter that is going to be the column name. So now this column name is exactly that specific column which you want to associate from the dimension table to the fact table. So for example, there is a specific table over here that is product lookup. So product lookup, we have already seen that it is a dimension table, and this product lookup is having one of the column that is product price, right? So for example, if I want to associate this product price column with respect to my sales data, just because in my sales data, I'm having one of the column and that is giving me the insight about the total product quantity. So with respect to each and every single product key, we are having the associated product quantity, that how much is the quantity for each and every single product, and that quantity we are going to multiply with respect to the product price, and that will be giving us an important column value, and that is going to be the revenue. So whenever you are working on any of the e-commerce project, it's always important to show to the stakeholders that what exactly is the revenue you are able to generate as a sum you can show, or you can simply show with respect to each and every single product, right? So that's why going forward with the revenue column is definitely going to be an important column. And that is one of the reason we will be making the use of this related function. So what exactly I'm saying over here is that you are making the use of a column from the dimension table, and that you are associating with respect to your fact table as a new table, right? But what exactly this will be creating is a kind of hindrance to the normalization, right? So as per the normalization, what exactly we were mentioning from our side, and that was each and every single table should come out to be as a single table which is delivering a specific information. So for example, territory lookups should give us the information about the territory itself. Then the customer lookup should give us the information about the customer detail itself. But in this case, why I'm making the use of related function, what exactly I'm doing is that I'm trying to associate the attribute. So attribute is the column. So I'm trying to associate the attribute from the product lookup table with respect to my fact table, right? So this will be simply coming up as a kind of hindrance to normalization. But at this point, you can see that definitely it will be creating some kind of duplicacy as well, or redundancy as well. But just because with respect to our scenario, creating this new column into my fact table is going to be important, right? Just because I have to come up with a column which is showing us the revenue. So sometimes you can simply go forward with this related function to come up with the redundant data as well. That is completely fine, but you should not overuse it, because overusing it will be simply coming up as a kind of hindrance to normalization, and that is something we definitely don't want. With respect to our previous statements that we were mentioning in our data modeling section, right? So this is something we will be looking into. So what exactly this related function will be doing is that it will be able to make the use of the column that is there in my dimension table, and that column I will be associating with respect to my fact table, right? So this is something we are going to do with respect to our related function, and we will be looking into that how exactly I can simply go forward with the complete formula. So formula is not exactly going to be that much difficult. We will be looking into it. And one more thing you can see over here, that whenever I will be trying to extract out the information from one of the dimension table. Okay, so let me go into my table view, and with respect to the, yeah, one more thing I was talking about, that we can simply go forward with this specific function, and this function will be helping me out to relate the column of my dimension table with respect to my fact table. And one thing you can see over here, that what exactly we are focusing upon at this point is the row context. right? Just because I will be taking the row that will be giving me the information about the product price from the product lookup table, and that I will be multiplying with respect to the similar row value that will be giving me the insight about the quantity of the product. So that quantity of product will be getting multiplied with respect to product price, and in a similar row, we will be able to generate out the revenue value. Right, so that's exactly how this revenue is being generated. We can simply go forward with row by row. Each and every single row will be getting multiplied with respect to the attributes you are having, and we will be able to come out with the revenue with respect to each and every single product category we are having. Right, so this is something we will be looking upon in this video, and let us jump back into our table view. So now in the table view, you can see that we are having one of the we are in the sales data, right? So in the sales data table itself, you can see that we are having one of the column that is order quantity. This order quantity column is required to be multiplied with respect to the product price, so that we'll get to know that how exactly we are able to come up with the revenue. So revenue we will be generating for each and every single product key. So for product key 360, what exactly is going to be the revenue that we are able to generate from it, that we are trying to calculate, right? So let us jump into the practical implementation. Let me create the new column over here from my sales data table. And I will be naming this specific column as the retail price. So that column which I will be extracting over here from my product lookup table, that I will be referring as a retail price itself, right? So let us name this column as retail price. Let us look into my column that is product lookup, or we can simply go forward with right. Yeah, let me go. First of all, we have to mention the function, right? So the function I'm going to make the use of is going to be related function. And as soon as I'm going to make the use of the related function, you will get to see one thing over here, and that is whatever tables are associated in a kind of one relationship. So just because my sales data is consisting of the foreign keys, so all of the tables which are having the primary key, which is associated with respect to our fact table, that you can see getting associated with respect to our table, right? So you can see the columns from each and every single dimension table that is there, that we can connect with respect to our fact table, so that we will be able to come out with the relationship building, right? Okay, so all of these columns we can see from multiple dimension tables that we are having. So let us get into my column, which is giving me the insight about the product price. So my product lookup table itself, I'm having one of the column that is the product price. And this column I will be relating with respect, or I will be simply creating a new column in my sales data table, that is retail price. And that will be associating the information from the product price column that is there in my product lookup table. So one thing you can see over here, that all the time we are trying to extract out the information from the one side, and into the many side, you will be able to extract out the information. So this thing you should always make a note from your side, that into your fact table only, you will be associating the tables, or you will be associating the columns. You won't be going forward with the dimension table. You will always be associating that column into your fact table itself via making the use of this related table from the dimension table, right? So that's why I'm not exactly going forward with any of the dimension table. I'm not adding the column in product lookup or in product categories lookup or in any of the dimension table, right? I'm always trying to associate the values into my fact table itself. That is the sales data, or I can go forward with the returns data, right? So let me create my new column, that is the retail price. And you will get to see that with respect to each and every single key, we will be able to associate a proper retail price with respect to it, right? Okay, so the kind of value we are getting is consisting of the decimal point as well, and that is not something we are concerned about, right? We are not exactly looking into the decimal point. What exactly we are looking into is a numeric point, right? So one thing you can do over here is that you can simply keep the number of decimal point up to 0. And you can see in a proper format, into a numeric format itself, you will be able to see the retail price. And this retail price, now you will be multiplying with respect to your order quantity, and that will be simply generating the new column that will be giving us the insight about the revenue. Right, so let us get into creating the new column itself. Let me get into my sales data table. Let us create a new column. All right, so in my sales data table, I'm having one of the column as the order quantity. Now I will be multiplying this order quantity with respect to my product price, right? Or the retail price. So I've named my column as retail price, right? So this is something I'm going to multiply. So this retail price will be getting multiplied with respect to order quantity. And in the similar row, we are going to have the product key, right? So for product key 360, you will be able to see that what is the total revenue that is being generated on the basis of multiplication of this retail price with respect to the order quantity. Let us click enter over here. We'll get to see the revenue column getting generated. Again, it is showing us the details into a format that is consisting of the decimal point. I'm not exactly interested in that. So I'm done with this thing. I'm able to calculate the revenue for each and every single product key. Let us see that whether if it is giving us a proper detail or not. Right. All right. So over here you can see that for the product key 528, for the product key 528, you are having the number of, so the number of sale you are having from product key 528 is coming out to be as 2. So 2 is the quantity of that product key, that is 528, and that I'm trying to multiply it with respect to the retail price. And from that itself, you are able to see that the revenue that is being generated from this specific product key itself is coming out to be as 10 rupees. Right, so this revenue column is working completely fine. We are able to extract out the information from each and every single row. So that's how great is the related function, right? By making the use of related function, you can simply go forward with the columns of the dimension table that you can associate into your fact table, and you can come up with some important calculations via making the use of this function itself, right? So that would be all in this specific video, and that is all about this related function. And now we will be meeting you in the next video with the discussion about the calculate function. So calculate function is one of the most important function that is there in DAX, and that we will be covering in the next video itself. So thank you. All right, guys. So let us get started with one of our most important function in the whole series or in the whole section, and that is going to be the calculate function. So why we exactly used to consider this calculate function as one of the most important function, because calculate function is going to be the combination of multiple functions, wherein whatever functions we will be learning in the next videos or whatever functions we have learned in the previous videos, this calculate function is going to be the combination of all of these functions itself. So we can come up with the calculations, or we can come up with this measurement which is going to be a bit complex, or which is going to be a combination of these multiple functions that we have discussed up till now, right? So from this point on, you'll get to know that why exactly the calculate function is helping us out to come up with some real solutions that we are looking for, right? So as a data analyst, whenever you are joining in a company and whenever you are working as a data analyst or business analyst, simply you need to come up with some important insights, right? In your report view itself or in this specific view itself, you won't be able to show some important result if you're not exactly making the use of these functions to come up with the insights which are already not there in your data set, right? As at the end of the day, if you are just delivering the result which are already there in your data set, then you won't be able to surprise these company, right? Your insights won't be surprising the company, right? That's because you have to deliver some important insights, and for calculating those insights, or in order to come up with those insights, you have to make the use of this calculate function. So calculate function is one such function which we will be making the use of for coming up with some complex solutions or some important insights. And from this video onwards, we will be moving forward with some more important functions that we'll be looking forward to, that will be giving us some important critical results that we can show to the stakeholders, right? So let us get started with the calculate function. So let me show you that what exactly it is. So I will be giving you a kind of description of it. So calculate function is going to be to evaluate an expression in a context that is being modified by the filters. So what do I exactly mean by this statement is that if you have already created a filter, let us say that if you are using a filter, or if you have created a measurement which is giving you the insight about the total orders, right? This order quantity is giving us the insight about the accessories, and then the bikes, and then the clothing. That what is the sum of orders we are getting from accessories, what is the sum of orders we are getting from bikes, and what is the sum of orders we are getting from clothing. But what if I'm only interested in the order quantity from clothing itself? So what exactly I want is that I want that order quantity should be given in such a way such that the category name should be clothing. So for that measurement that I will be creating, if that measurement, if I will gonna drag and drop it over here, then this value that you will get to see, that is 12436. That is the order quantity when the category name is clothing. That value you will get to see for the accessories as well, bikes as well, or for the clothing as well. Right? So you can call this calculate function as a kind of extension of filter. So the filter that you have already applied over here, for let us go forward with order quantity itself. So for order quantity measurement, the filter that you have applied was the category name. So on the basis of category name, we were simply coming up with the order quantity, that with respect to each and every single category, what is the order quantity we are getting, right? But now I'm coming up with the extension via making the use of this calculate function, that now the category name should be clothing itself. So only for the category name, that is clothing, I will be calculating the order quantity, right? And that is what a calculate function is. So calculate function will be helping you out to come up with an extension of filter, wherein already if you have applied a filter, then you can come up with the extension of it, or a kind of upgradation or a modification of it. So you will be modifying your already applied filter via making the use of this calculate function. So calculate function, let me write it in simple words for you. I won't be going into the definition of it. So you can call your calculate function as a filter modifier, right? This filter I have already applied on the basis of category name for the order quantity, and now I'm modifying it such that I'm only looking forward to the category name that is equal to clothing, right? So this is a kind of extension I'm coming up with, right? So you can call it as a kind of filter modifier, and it will be used for modifying your filters, right? So something like that you can call your calculate function as, and definitely it is a kind of critical function, just because in the next videos we will be looking into that how exactly a combination of functions we will get to see inside this particular calculate function itself. So that's why you can call it as a container as well. So it is like a container, right, for other formulas. So why exactly I'm calling it as a container? Just because it will involve the combination of other functions as well into it, right? That we will be looking into the next upcoming videos. So it will be called as a filter modifier or an extension of filter, and it will be used to modify your filter context, right? So one thing about filter, about the calculate function is that if you have already applied a filter, and now, like for example, one example I was considering at this point, and that was I was using this filter, and that was a category name. So on the basis of this filter, I was calculating the total order quantity, right? But then I said this statement that we are interested in now the order quantity when the category name is coming out to be clothing only, right? So So what exactly I was saying was that what kind of filter I was applying at this point was the category name, right? So on the basis of category name, we are already looking forward to that what is the order quantity we are getting. And now one more filter I was applying over here, and that is when the category name is coming out to be clothing, then I'm looking forward to the order quantity, right? So when I will calculate this specific measurement by making the use of this calculate function, you will get to see that that specific measurement that you are coming up with by making the use of calculate function, that is the order quantity when your category name is clothing, that value that is 12436, that you will get to see associated with respect to accessories as well, bikes as well, and with respect to clothing as well. So the filter that you have already applied on the basis of category name, that you won't be able to see that as a important filter, which is giving you the insight about the order quantity. So a kind of overruling kind of nature you will get to see whenever you are going forward with the calculate function, that we will be showing you in the practical implementation itself, so that you will get to see that what exactly do we mean when we are saying that calculate function is involved in overruling the rest of the filters which are already being applied, right? So, first of all, let us get into the practical implementation of it so that you'll get to know that what exactly is the syntax. First of all, let me show you the syntax of calculate function. So, calculate function is having its function name as calculate, and the first parameter that you have to pass over here, that is going to be the expression, right? So this expression is going to be that specific measurement that you have already came up with. So I was discussing one of the scenario wherein order quantity I was using, and then onto this order quantity I was applying another filter, right? So this order quantity as a measurement you can pass on as an expression over here. In a similar way, returns quantity is also one of the measurement which we came up with. So this returns quantity you can also pass on as an expression over here. In a similar way, average retail price can be passed as an expression. So you can get this idea that whatever measurements which we already came up with, that measurement you can pass on as an expression over here. And now on to this specific measurement that you are passing on as the expression in your calculate function. Onto that, you can apply a new filter, right? So that depends upon how much. So it's completely up to you that how many number of filters you want to apply. Like like I can go forward with as many as number of filters as I want to apply, right? So what exactly this expression is giving us the idea about, or what exactly this formula is giving us the idea about, is that this calculate function will be having its first parameter as the that specific measurement onto which I want to apply my new filter. So this filter is going to be like a where clause, right? Just like in SQL, we are having this where clause which used to help us out in applying some specific condition, and on the basis of that where clause itself, or on the basis of that condition being true itself, we are able to extract out some important insights. Like for example, if I'm using this command as select star from my table name, and then I'm putting this condition where employee name is equals to this. So you will get to see the records of that specific employee itself, right? Whose name you are passing in your where clause. So that's exactly how this calculate function used to work. So the calculate function in your filter, you will be working just like that where clause itself, right? You are putting a condition, and on the basis of that condition, now this expression will be evaluated. So let me show you the practical implementation of it so that you'll get to know that what exactly do I mean by this when I'm saying that these filters are deciding the value of your expression or the value of your measure, right? So let us get into the practical implementation. So now we are having one of the, so I was having this insight that was the order quantity, right? So this order quantity was giving me the insight about that what all number of orders I'm getting from these specific category name. But what if I'm interested in those specific orders which are, or what if I'm interested in total orders when the order quantity is coming out to be greater than one? So what do I mean by that is that, for example, if bike is being sold for one time only, right? Or if clothing is being sold for two times, it is being sold for one time, and it is being sold for three times as well. So I'm only interested in getting the total orders for clothing when it is being sold for more than one time, right? So I'm not interested in that specific scenario wherein wherein only one cloth is being sold in an order. What exactly I'm interested in is when multiple number of orders I'm getting from clothing. So just like the example of clothing, this expression or this value that is greater than one will be applicable for bikes as well, accessories as well. So what exactly I'm interested in is calculating the total orders when the order quantity is coming out to be greater than one. So let us look into that how exactly we can go forward with it. So now in my table measure itself, I can go or let us go forward with my sales data, right? So the sales data table itself, let me calculate the new measurement. This definitely calculate is going to be a measurement itself, just because you are passing on this measurement into your visual, right? You are not exactly calculating a column over here. So whenever my order quantity is coming out to be greater than one, then I will be calculating the order quantity, right? Order quantity is same as that of total orders that I was getting. So I will be calling this as my bulk orders. So bulk orders will be calculated when your order quantity from the sales data table is coming out to be as greater than one. So in the calculate function, what exactly you have to pass on as the first value is going to be that specific measurement which you want to calculate. So there is a kind of trick whenever you want to pass on measurement as a value into your function, and that is to make the use of the square bracket. So whenever you're making the use of the square bracket, you will get to see the name of all of the measurements that you have already calculated, right? So what exactly I'm interested in at this point is the total orders, right? So total orders will be giving me the insight about the sum of orders which I'm getting from accessories as well, bikes as well, and clothing as well. So this is something I'm interested in at this point. And now with respect to, so now onto this total orders only, I will be applying my additional filter, right? So this calculate function, you can just simply go forward with this way, wherein you can refer this statement as calculate function is able to apply the filter onto the first expression that you're passing over here, or calculate function is applying the filter on the first measurement that you're passing over here. So now in our specific case scenario, this whenever the order quantity is coming out to be greater than one, then in that case, so you can say that the calculate function is applying the filter on total orders when the order quantity is coming out to be greater than one. And from that, we will be able to come up with the bulk orders, right? So let me show it to you what exactly do we mean by that once it is being evaluated. Now we are ready with our bulk orders. Let us look into that what exactly we are getting from this. So let me drag it and drop it over here. Let us not look into the order quantity at this point. I'm interested in looking forward to my bulk orders, right? Okay, total orders I'm quite concerned about at this point, just because total orders is giving me the insight about that what is the sum of orders I'm getting from accessories, bikes, and clothing as well, right? And along with total orders, what I'm exactly interested in is my bulk orders, which I've just calculated at this point. So now this bulk orders is giving us the insight that there are 21,211 number of orders which are there from accessories, wherein a specific order or a specific quantity is being ordered for more than one time. Right, like you can get the insight from this bikes row itself that just because in any of the order, just because bike is not exactly being ordered for more than one time, right? So that's why there is no bulk order we are getting for bikes. But in the case of clothing, definitely in an order that specific product might, or that specific cloth might be ordered for more than one time. And that's why we are able to see some value for bulk orders with respect to clothing. Right, so that's exactly how it used to work. So you can get this idea that this bulk order is putting an additional filter, right? So onto my total orders, I'm putting an additional filter that the order quantity should now be greater than one, and then you should come up with the total orders, right? So I'm not getting the same value for the total orders that is 33607 with respect to my bulk orders. Just because by making the use of this calculate function, I am putting a one more additional filter over here, right? That's exactly how this bulk orders used to work. So that's exactly you will be able to come up with the bulk orders. And one more thing I would like to show it to you over here. That is how exactly we were mentioning this thing that calculate function is capable to overrule and filter that you have already applied. Like over here, you can see that the total orders for each and every single category name is coming out to be on the basis of what exactly is a category name, right? Like total orders for accessories is coming out as an appropriate number. In a similar way, total orders for bikes is also coming out to be as an appropriate value. But one thing I can show it to you over here, that is when I will be applying the calculate function, wherein I'm only concerned about the category name as bikes, then this specific value you will get to see that will be getting that will be overruling over these specific values. Right, so let me show it to you practically so that you will get to understand it more clearly. So let us get into my sales data table itself. Let me create a new measurement. All right, so what exactly I'm interested in is the category orders, right? And now let me make the use of my calculate function for, so what exactly I'm concerned about. So first of all, you have to pass on your first expression as the first measurement that you have created, just because I'm interested in the total orders. Now in the total orders, I want to put my first filter as that from the, so category name is in the product lookup table, right? I think, or I think it is in product categories. Yeah, it's in product categories. So what exactly I'm looking forward to, that whenever my product category name is coming out to be as bikes, then I should evaluate this value, right? Okay, so what exactly I'm interested in is, so when my category name should come out to be as equals to bikes, right? This is something I'm concerned about. So I'm calculating the total orders when the product subcategories lookup category name is coming out to be as bikes, right? So let us see that what exactly we are getting as a category orders, right? So once it is being evaluated, all right, let us see the value of it, that how exactly it is overruling the category name value that we are already getting, right? So into our sales data table itself, we are having one of the measurement as category orders, and you can see one thing over here, that now this filter is not exactly working, right? The category name which was already there. So already we were applying a filter that is a category name for calculating the measurement that is total orders. As this specific value is coming out to be as total orders itself, right? And now this total orders is being evaluated on the basis of this category name. But once I'm applying an additional filter via making the use of calculate function, then that specific filter overrules over the already applied filter, right? So now this additional filter is not at all now this additional filter is coming out as a kind of overruling filter over the original filter, right? So that is why calculate function is so special. So already if you have applied any filter that won't work with the calculate function, and that is the reason why we always used to prefer it. So it will be a kind of overruling, or it will always take priority, you can say. So whatever expression you are calculating, whatever kind of rule you are putting onto your expression or onto your measurement, so that will be always taking a kind of priority over the other filter that you have already applied. Well, that's exactly how this calculate function used to work. And one more example we can look upon at this point is, let us see that what is the orders we are getting for the weekend. So we have created one of the column in the previous video, and we will be calculating that what exactly the orders we are getting for weekend only. So maybe if the company is interested in looking forward to the orders in weekend itself, and they're trying to increase their sale in weekend as only, just because they might would have found this data that the customers are buying mostly in weekends itself as compared to that of weekdays, right? Just because weekdays are the office days, so they won't be ordering a lot on the weekdays, right? So let us first of all see this insight. Let us first of all calculate that insight, right? So let me come up with my new measurement. And yeah, all of these measurements that you're calculating over here, you can simply pass it on to the table measure itself. One thing you can see is that from my home table, I will be passing it on to that table measure table. From home table, you can select it out. In a similar way, this category orders as well, you can pass it on into your table measure itself. Now, once we're done with this, let us move forward with our next example, and that is to get the insight about the total orders we are getting on weekends, right? So now into my table measure itself, I will be calculating my new measurement. And let me name my new measurement as weekend orders. So you have to make the use of the calculate function. Now this calculate function will be calculating the total. Always make the use of square bracket. So you'll get to see that what exactly the measurement onto which you are applying an filter, right? So on total orders, I'm applying a kind of filter. And what is the filter we are applying? Is that from the calendar lookup table, that specific column that was giving us the insight about the weekend or weekday. So I'm only interested in weekend, right? So I will be calculating the total from by making the use of this calculate function. I will be calculating the total orders when the day is coming out to be a weekend, right? Let us evaluate this value. Now we are able to come up with a new measurement. Let me drag it and drop it over here. Right. So now you can see that on weekends, how many number of orders we are getting from for accessories, and in a similar way, how many number of orders we are getting for bikes and for clothing. Right. So this insight you can again get by applying the additional filter from calculate function, right? That's exactly how this calculate function used to work. And in the upcoming videos, we will be looking into this aspect, that how exactly this calculate function will be working with as a kind of container, so that other functions as well I can involve in this specific function itself, so that I can come up with some complex measurement, right? So all of those insights you will get to see, but definitely this calculate function you should try out from your side as well, so that a kind of more quick hands-on you will get on it. And just because it is a kind of very important function, right? As in the upcoming videos, we will be making the use of this specific function itself for coming up with some complex measurements, right? So we will be meeting you in the next video with some more important insights, and that would be all. So thank you. All right, guys. So let us get started with one of an important topic that we haven't discussed up till now, right? So up till now, we were focusing upon these things, that is the multiple function that we are having, and we have explored about an important function, that is the calculate function, and how exactly this calculate function is going to be related with respect to each and every single other function that we are going to discuss about in the next upcoming videos that we will be looking upon. So that's why discussing about the calculate function was too much important. But at this point, let us focus upon one thing. And before talking about this thing, let me show it to you practically and what exactly I'm talking about. So in my rows, let me show you a value that is giving me the insight about the multiple categories, right? So I'm having the category name over here. And with respect to my category name, let me show you some important details. So with respect to the category name, let us see our total orders, right? So in my values, I'm calculating the total orders. All right. And in this total orders, let us see the formula of it, that what exactly this total orders is representing to us. So total orders is representing us the count of all of the order quantity I'm having, right? But let us see, let us look upon one thing, that is what is the distinct orders we are getting with respect to each and every single order number that we are having. First of all, let us see that what exactly I'm talking about. So in my customer lookup table itself, I'm having one of the column that is giving me the insight, not exactly in the customer lookup table, in my sales data table, right? In my sales data table, I'm having one of the quantity, I'm having one of the column which is giving me the insight about the order number. So this order number will be having all of the orders. Like in this specific order, I'm going to have the multiple products which are being ordered by a particular customer. That's exactly what order number is showing us, right? So in this specific order, that is SO 47212, we are going to have multiple products which will be ordered by a particular customer, right? So let us look upon, so let us get into an important insight, or let us calculate an important measure, which is giving me the distinct count of all of these orders, right? So distinct count will be simply calculating the complete count of all of the values which I'm having in this order number. And what exactly I'm looking upon is the distinct value. So if there is a specific value like SO46736, if that is getting repeated, so that repeated value we won't be getting, we will be just getting that count for one time. So for example, if this specific order number is being repeated for 5 times, so the distinct count for it will be giving me the value as 1 itself. So those 4 repeated values won't be shown into my final distinct count, right? But this is something I'm trying to calculate at this point, and let me go into my visual itself and let me show it to you practically that what exactly we're calculating. So into my table measure, I'm calculating a new measure over here. That is orders distinct count, right? And this should be equals to the distinct count you are having in your sales data table order number. Let us see the value of it, how exactly this measurement is getting created, and let us plot it with respect to our category name. Right, we're done with this. Let me show it to you in the values. All right. So over here you can see one thing, and that is, so the sum of all of the count, the count you can see over here. So if I'm just calculating the count of all of these orders, so what exactly it is coming up, right? Let me show it to you over here. So in my calculator, let us see the value of this count, what exactly it is. So 16983 plus 13929 plus 6976. So you can see the total count is coming out to be as 37,888, right? But what is the total value we're getting in this scenario? So the sum of the total order distinct count should come out to be as 37,888, right? But we are not exactly getting the same value when I'm looking upon this specific total value in my visual, right? So you can see that there is going to be a kind of significant difference at some point of time whenever I'm trying to calculate the value, whenever I'm looking upon the total value with respect to the multiple filter I'm putting. And this is what exactly we are talking about in this specific video. So in this specific video, what we are exactly talking about is the DAX measured totals. So this measured total sometimes can come out to be incorrect, or it can come out to be as inconsistent, just because it depends upon that how exactly you're calculating your orders, right? How exactly you're calculating your measurement. So at this point of time, you won't be able to see a kind of significant difference. And in some of the scenarios, exactly won't be able to see a difference in the sum of these values and the total value. But in this case, why exactly we're getting this significant difference? So in order to show you that, I have already shown you the formula as well. So you can think from your side as well, that when I'm trying to calculate the distinct count, why exactly the sum of all of these values is not coming out to be equal to the total value, which is being shown over here. So the reason behind it is that the DAX measure totals doesn't really add up with respect to whatever visible values that you can see on the screen. So whatever visible values are being shown onto my matrix, that is these values that you can see with respect to your category name, DAX doesn't really is not exactly concerned about these values. So what exactly DAX is concerned about is the total number of distinct orders that we're having, right? So the total count of the distinct orders that we're having is around 25,164. And that is not at all related to the kind of filter you're applying over here. So as per the filter, you are able to come up with an answer that the accessories is is in my 16,983 orders. In a similar way, my bikes is in 13,929 orders, and my clothing is in 6,976 orders, right? And what exactly it is. So what exactly this data is representing to us is that you can simply say this in a statement that the accessories are present in 16,983 orders out of 25,164 orders, right? So these specific values that you can see on the screen, that is 16,983, is not exactly different from these specific values that you can see with respect to the other category name. And what do I exactly mean by that? Definitely, a customer can buy an accessory and clothing both in a single order itself, right? Like, for example, tomorrow, if I'm ordering something, then in my similar order, I can go forward with ordering a cloth as well, and I can order accessory into the single order itself, right? It's not a kind of compulsion that every time when I'm ordering something, then I should buy clothes in an individual order, and then I should buy the accessory in the individual order. That is not a kind of concern which is being put upon me, right? And that is what this total value mean over here. So this total value, what exactly it is representing to us is that out of all of the distinct counts we are having. So distinct count is giving us the insight about the distinct orders that the customer is making. So in each and every distinct order, the accessories is appearing in 16,983 orders. And in those 16,983 orders, there are going to be some set of orders which are having bikes into it as well, right? In a similar way, the orders which are having accessories into it, that is this specific number, that is 16,000 or 17,000, let us go forward with. So in this 17,000 orders, we can have the clothing included in it as well. Right, so it's not a kind of compulsion all the time that these values that you can see on the screen would come out to be as individual itself, as we can have the overlapping values, as the value for bikes and clothing can overlap with respect to this specific value as well. Or you can simply make this answer from your side, and that is out of these 17,000 orders, there are going to be some orders in which clothing will also be appearing and bike will also be appearing. And that's why the total order is not exactly concerned about these individual numbers, and it is just concerned about the total number of distinct count that you are getting. So whenever you are looking upon this specific value, that is a total value, you should never be concerned about the sum of the values which you are getting for each and every single filter, right? Just because the total value is never concerned about what filter you are applying. It is just concerned about the total value that is there, right? So that's why never you should go forward with the total value as the sum of these filter values. And that is what we want to show you in this specific video, right? So that would be all in this video, and we will be meeting you in the next video with our next set of functions, and we will be showing you that how exactly calculate is coming out to be an important function with respect to those functions that we are going to discuss in the next video, right? And how exactly calculate is coming out to be a container function that we will be showing you in the next videos. So that would be all, and thank you. All right, guys, so let us get into our fifth assignment, and this will be regarding the calculate functions, right? So just because we have discussed about this thing that calculate function is one of the most important function in this whole section. So that's why assigning an assignment with respect to this function is going to be quite important, right? So let us look into each and every single key objective. So our first objective used to tell us that we have to create a new measure with the name as bike returns to calculate the total quantity of bike returns, right? So already in the previous video itself, we have seen that with respect to total orders, what is the total orders we were getting specific to bike only, right? So in this specific key objective, you have to simply look forward to the total number of returns that you are getting for bike. So the similar kind of criteria you have to apply just like the previous video, just in this specific scenario. The expression that you will be passing is going to be the total returns instead of total orders, right? Then you have to create the matrix to show bike return values by start of month rows. We have also specified the filter for you. So the filter is going to be start of month, and then the bike returns is going to be the values, right? That is going to be the attribute. Then what do you notice about the volumes of bike returns over time? So simply you can look upon the value. So whatever values you are getting for each and every single month, you can simply look upon that whether if you are coming up with an increase in bike returns or if you are coming up with a decrease in bike returns as per the month, right? So that idea you can get from the second objective itself by plotting these bike return values in your matrix, right? So now the third key objective is telling us to create a new measure with the name as bike sales to calculate the total quantity of bikes sold and add it to the matrix. What do you notice? A similar kind of expression that we have discussed in the previous video itself, right? So just if you're not able to solve these objectives on your own, it will be a better thing to go forward with the previous video itself so that you can become more comfortable with these objectives, right? In a similar way, you can go forward with creating a new measurement with the name as bike return rate in the fourth objective. So you have to come up with the new measurement as bike return rate. So you can simply go forward with the calculate function or you can go forward with the divide function and you have to add it to the matrix, right? So whatever return rate you are getting, so whatever is the bike total returns you're getting, that you can divide with respect to your bike sold, right? So bike returns upon that bike sales will be giving you the complete insight about the rate. And one more thing you have to look upon over here, and that is just because you're calculating the rate over here, so rate is always being evaluated in percentage. So you have to make sure that the format for this division is coming out to be as percentage itself, right? And then finally, the fifth objective is how would you respond to the product VP is concerned about this rising bike returns, right? So that will be completely dependent upon the second key objective. So whatever important insights you can come up from your second key objective itself. So how exactly you can respond to these concerns to the product VPs, you have to simply come up with that. Right. So these are going to be the 5 objectives that you have to solve from your side, and we will be meeting you in the next video with the solution of these 5 key objectives, right? It's not exactly too much difficult. We have discussed about this calculate function and the practical implementation in the previous video itself. So it won't be taking a lot of time for you, right? So definitely try it out from your side and let us meet in the next video with the solution of these key objectives. So thank you. All right, guys, so let us get started with the solution of these key objectives that is there in the fifth assignment. So our first key objective is suggesting us to create a new measure named as bike returns to calculate the total quantity of bikes that are returned, right? So the similar kind of function that we were discussing in the tutorial itself, that was regarding the total number of orders that we were getting with respect to bikes, right? So in a similar way, we have to calculate the total bike returns. What exactly we need to do over here is that we simply need to pass on the value as, again, the category we have to pass as bikes, but the measurement that we are going to pass at this point of time is not going to be total sales, but it is going to be total returns, right? So just a kind of change you have to make in that calculate function itself, and you will be able to solve this objective, right? So let us jump into our Power BI. We have already shown you the category orders, and in the category orders itself, you might would have seen the approach to go forward with bikes. And now let us go forward with the similar approach to come up with the total returns, right? So let us get into the measurement itself. Let me click over here. Let us create the new measure. And you will get to see the similar kind of formula that we were discussing in the previous video itself. So let us name our new measure as per the key objective. So we have to name it as bike returns, right? So we have to name it as bike returns. And then let us go forward with writing the function as calculate function. And now in the calculate function, over here, only the change you have to make from your side is to go forward with what expression we should make the use of, right? As in the last case, we were going forward with total orders, right? But at this point of time, we won't be considering total orders, but we will be looking into total returns. So now with respect to total returns itself, I have to make the changes wherein I will be selecting. So with respect to total returns, now I will be selecting my category name from the product subcategories table. From the product categories table, So my product categories lookup category name should be bikes over here, right? And now we are able to do it, right? So what we are exactly doing is that we are calculating the total number of returns, but what exactly we are displaying at this point is the total number of returns with respect to the bikes, right? So we can go forward with it. Let us see the value getting evaluated. All right, so we are done with the creation of it, and let us see with respect to monthly what exactly we are getting, right? So in our matrix, we have to show in the rows is the start of the month, right? So in our calendar lookup table itself, we have created the start of the month. Let us plot it into the rows. And now with respect, okay, we have to put start of month, right? All right, once we are done with that, we can go forward with putting the values. Okay, don't choose the start of month from the hierarchy because that will be giving you some a kind of kind of tree kind of architecture. So that is not something we are looking upon at this point. Let us go forward with the proper column that is start of month. Once we're done with the start of month, let us look upon our measurement, right? That is a bike returns, right? In our values itself, we will get to see that we are having one of the measure as the bike returns. And now we are able to see the values, right? We are able to see the total number of bike returns with respect to the start of month. So we can see the values at how many number of bike were returned in the month of January in 2020, and we can see a kind of significant difference. So at some point of time, the returns is increasing with the increase in month. As you can see in the month of in the final year 2022, we are getting a significant increase in the bike returns. As in the previous years, we're not exactly getting a significant increase, but you'll get to see that the values are rising from year 2021 to 2022. But let us see that how exactly the impact is there with respect to the bikes that are being sold. So whether if we are having a kind of great value for bikes sold with respect to the bike return. So if you are getting a great value with respect to bike sale as compared to bike returns, and definitely these values won't matter, right? And at the time when we will be calculating the rate of bike returns, we won't be able to see a kind of significant great value, right? So let us calculate our third value. So at this point of time, they were asking you to that what do you notice about the volume of bike returns over time? So one thing we can see over here that the value is not exactly coming out to be a kind of proper proportionate value, right? It is not exactly increasing. It is not exactly decreasing. A kind of disproportionate value you can see with respect to start of month. So in a similar way, let us go forward with the third objective, and that is to create a new measure that is bike sales. And over there, we have to calculate the total quantity of bikes sold, and we have to add it into the matrix itself. So this bike sale is also going to have the similar kind of formula. Let us go forward with creating it. So into my table measure itself, I will be creating my new measure as bike sales, right? So my measure name is going to be bike sales. We have to calculate. Let us go forward with what exactly we should go forward with. So yeah, in this specific scenario, you have to make the use of order quantity as the measurement, right? So you won't be going forward with any other measurement, but at this point of time, let us go forward with order quantity as the measure itself. And now with respect to order quantity, what I'm calculating is with respect to my product categories, my category name should be bikes. right? So I'm calculating the order quantity for bikes, right? So that will be giving me the insight about the bike sales. Let us see this measure getting created, and we can simply plot it into the matrix itself. And now let me plot it. And now we can see a kind of great value, right? A great increase in the value of bike sales. So you can see that this number, that is bike returns, is not exactly creating a kind of great concern as per the values we are getting for bike sales. So with respect to the value that is coming in 200 or in 600, definitely 26 value won't be creating a kind of great impact over here, right? But definitely, if the value in bike returns is increasing, so in a similar way, we can see a kind of significant increase in the bike sales as well. So as compared to the increase, the increment that we are looking into the bike returns as compared to that of the increment we are looking into bike sales, that increment in the bike sales is coming out to be great as compared to that of bike returns, right? So that's why definitely you can come up with this answer that the impact of bike returns won't be creating a kind of huge impact in a kind of negative way on the bike sales, right? From these numbers itself, you can come up to this conclusion, right? Let us see our upcoming objectives, and then we'll come to the final conclusion. All right, so we are done with this. They were asking us that what do you notice? So we can notice about this thing that the bike sales is significantly increasing with respect to time. And definitely the increment in returns is not exactly creating a kind of huge concern for us with respect to the numbers we are getting for bike sales. Right? And then we have to go forward with creating a new measure that is named as bike return rate. Right? So already we have created one of the measurement that was return rate, right? So now we can simply go forward with that specific measurement itself, and that into that measurement we will be just passing on the category's name as bikes. So again, it won't be a bit difficult for us. We won't be making the use of divide formula at this point of time. Let us go forward with the previous measure itself. Into my table measure, I will be creating the new measure as bike return rate, right? All right. Okay. Bike returns rate. Let us name it as. Okay. So bike returns rate, we have to calculate the total number of. We have to calculate the return rate, which we have already calculated, right? So we have to calculate this return rate when our product category name is coming out to be equal to bikes, right? So in that way we can come up with this bike returns rate. And now let us see that what we are getting over here. And if it is not being shown into a percentage format, you can simply go forward with the keeping this particular option on, right? So this will be making sure about this thing that you are getting the rate in a proper percentage format itself. And one of the most major reason why we are calculating this return rate over here, so that we can come up to this conclusion that the significant increase in the returns, whether if it is creating a kind of huge impact onto our bike sales or not, right? So these numbers that you can see, that is 2, 6, whether if these values are creating a kind of huge impact onto these numbers or not. So we can come to a conclusion, right? So this percentage will be giving us a kind of conclusive value at whether if you're getting a huge impact or not, right? So that conclusion you can show it to the VP itself. First of all, let us plot it. So now into my matrix itself, I have to drag it and drop it. Okay, it is not being shown into a percentage format. Again, what you can do from your side is that with respect to your bike return rate, you have to click over there, and then you can click on this percentage. So that a proper kind of value you can get. Okay, so you can see that the return rate is coming out to be in 2% or max to max 6. Or mostly it has been coming out in 1, 2, or 3% only. So definitely we are not able to see a kind of huge impact with respect to return rate on the sales rate, right? I mean, definitely if the return rate with respect to sales rate is coming out to be 1 or 2%, then still even if we are getting some returns on bikes, the sale is completely neglecting that value. So a value like 4 or 6 on behalf of 200 or 300 won't be creating a kind of huge impact, right? So this conclusion you can definitely come from your side. So just because if the VP is not exactly interested into these numbers, then you can show the VP this percentage, and you can definitely tell the VP that this percentage simply show us that the increment in the returns or whatever that proportion value is not exactly creating a huge impact for us on the bike sales just because of this percentage value that you can see over here. And in any of the months, let us go forward from 2020 to 2022, you can see that in every month we are getting the difference from 2 to 3% itself, right? So definitely a kind of average you can get as 3.08%. So 3% is going to be the average percentage that you can get. So definitely you won't be getting a kind of huge impact on the sale just because of your returns, and that conclusion you can come from your side. So the last objective that they were asking for, that is how would you respond to the product VP's concerns about rising bike returns? So definitely there is not exactly a concern for us. The value that we are getting for bike sales is completely accommodating the value that we are getting for bike returns. So there is no such huge impact of bike. All right, guys, so let us get started with our new function, and that is going to be the all function. So we were discussing in the previous videos itself that we are going to make the use of this calculate function as a container function, which will be used to come up as a function which will be used to store the other functions, right? Like for example, if I'm considering all function in this case, so I will be putting this all function into my container function itself, or I will be putting this all function into my calculate function itself to come up with some complex calculations. Right. So one thing I want to do over here before exactly discussing about about the all function, and that is in the last video we were calculating something, right? We were calculating that we were looking into that example of the distinct orders that we are having, right? So first of all, let us have a look upon that formula. So we were having this measurement that was giving us the idea about the distinct count of the orders. But one thing I would like to show it to you over here, that your total orders that you were calculating over here, that should actually be the same as that of the distinct orders that we were calculating, right? That's because it's total orders, why exactly we were calculating it, to get the idea that what exactly is the distinct count of all of these order IDs that I'm having. So that the company will get to know that what exactly is the distinct count which is coming for them, right? Or what exactly is the total orders they are able to get from the customer side within these 3 years. So that is something we need to calculate from this total orders, right? So that's why what exactly I will be doing at this point is that I will be simply going forward with deleting that specific orders distinct count which I was calculating in the previous video, and let us delete this from the model. And now this orders distinct count which I just calculated, that I will be showing to you with respect to my total orders, right? So now with respect to my total orders, I'm exactly interested in the distinct count. So now this total orders will be consisting of that value, that is the distinct count of all of the order number I'm having, right? This will be giving you the insight that what is the total orders the company is getting within these 3 years, right? So let us look upon this value, and now once it is being evaluated, let us put it over here. All right, so into my category name, let me show you the value for total orders, what exactly it is coming. All right, so now we're exactly getting a total proper value, right? So what exactly I want to show to the company is what is the total orders we are getting within these 3 years, and that is something we can represent by this specific measurement itself. Just because this specific measurement we are calculating as total orders, because when I will be showing you the KPI reports or when I will be building this dashboard in the next section, you will get to know that why exactly the total orders value should represent the individual orders itself. Just because whenever you will be building these dashboards in the next section, you will get to know that you have to report, or you have to create the report in such a way such that that should be representing the values like total orders, total returns, and all of these values should be represented in these multiple cards, right? So that's why naming a specific measurement in a proper way is going to be an important aspect that you have to consider from your side, right? So that's why we were calculating the total orders in this way. And now let us go forward by discussing about what exactly is my all function, right? Let us look upon one of the measurement as well, so total returns. So now with respect to total returns as well, I think I can simply go forward with a similar kind of formula as I can go forward with distinct count, so that we are on a good page, right? At the time when I will be creating the dashboard, I won't be getting some kind of, I won't exactly be getting issues, right? While I will be going forward with creating it. Okay, so I'm interested in, first of all, let us have a look upon our returns table, what exactly it is consisting of. Okay, I think returns quantity is completely fine. We are not exactly interested into that return ID or something. Okay, so there is no requirement to make the changes into the return quantity. We are absolutely fine with that measurement that we have calculated. Let us go forward with total returns. We need to keep the same formula as it is, but with respect to total orders, why exactly I was showing it to you in this specific video itself, so that it will be more clear to you that when you are naming a specific measurement, how exactly that measurement should be named, or how exactly a specific value in the measurement should display a specific information itself. So when you are saying this thing that you are representing total orders, and that should represent the individual orders itself, right? So that's why naming a specific measurement in a proper way and displaying the proper convention with respect to that name is quite important. And that's why we were showing it to you in this specific video itself. Okay, so this will be representing the total count of the return quantity. Okay, we are done with that. Let us look upon our other measurement as well. Okay, return quantity is completely fine, and let us have a look upon our order quantity. That is also fine, right? So we have discussed about that what exactly should be total orders for us. So when we will be going forward with creating our dashboard so that we can have a kind of proper convention, right? So these changes you can make from your side as well, so that when you will be creating the dashboard with us, so you won't be facing any issues, right, from your side. All right, so we are done with this thing. Now let us move forward with discussing about all function, right? So all function is going to be an important function. Let me first of all give you a kind of definition for it. So all function is a way to return all of the rows in a table or a column, irrespective of all of the filters applied, right? So what exactly you're getting from this all function is that, for example, if I'm interested in looking forward to all of the rows that are present in my table, right? Like for example, with respect to my total orders that was coming out to be as 25,164. So now with respect to this value that is 25,164, if I don't want any filters to be applied onto this total value, then what exactly I can do from my side is that I can simply make the use of this all function, and inside this all function, I will be passing this table that is there, which is consisting of the information about the total orders. And after passing that, I can make sure about this thing that now any filter, like the category name which is being applied over here, So any filter like category name or any other filter won't be playing any effect into the value that is 25,164. Right. So let me show it to you in a, so when I will be showing it to you in a practical way, it will be more clear to you. But first of all, let me show you the syntax for it, right? So that I can explain it to you in a more better manner. So all function will be having its syntax like this. You have to simply go forward with writing the function name as all, and then as the first parameter, you have to pass the table name or the column. So this specific table that you're passing over here, right? This specific table or the column name is going to be that specific table where I don't want any filters to be applied, right? Like for example, if I'm interested in getting all of the rows that are present in my sales data table, and now with respect to each and every single row that is present in my sales data table, I don't want any filter to be applied on it, right? So even when I'm dropping that sales data table into my matrix visual, so these filters won't be affecting any role or won't be playing any kind of crucial role in changing the value of all of the rows. If I want something like that, then I can simply go forward with this all function. So all function will be making sure about this thing that whatever table name or whatever column you are passing into it as a parameter, so onto that specific table name or onto that specific column, there won't be any effect of the filter that you are applying from your side, right? But this is something you can get whenever you are going forward with the all function, and into a syntax itself, you can go forward with writing some more column name as well. So yeah, even if you're passing the table name or even if you're passing a column name, that is completely fine. One thing you can make sure that now as the first parameter, if you're passing the column name from a specific table, now with respect to the similar table, like for example, the given table is consisting of 10 number of columns. And now the first column from the table name if I'm passing, and then if I'm interested in one more column from from that same table onto which I don't want the filters to be applied, then as the second parameter, I can pass on that column, right? So out of those 10 columns, I'm just concerned about those two specific columns onto which I don't want the filter to be applied. And that's why that specific column onto which I don't want the filter to be applied, that I can pass as a parameter over here. And in a similar way, you can pass on one more parameter, that is column 3, like that. Out of the 10 number of columns that are present in your whole table, whatever is the number of columns you want onto which the filter shouldn't be applied, that is something you can pass as a parameter onto your all function, and you will get to see that the total number of rows that are present onto that specific column itself, that is something you are able to return when you are going forward with this all function, right? So let me show you the, so in other words, I can call my all function as per the discussion as my filter remover, right? You can refer your all function as a kind of filter remover just because any filter that you are applying, like in with respect to the previous example that we were discussing with respect to calculate function. So in the case of calculate function, what exactly we were doing is that we were trying to apply a filter from our side onto a measurement that we have already created, right? So we have already created a measurement and now I want to apply an additional filter on it. And then I was going forward with the with the calculate function. But in this specific scenario, when I'm going forward with all function, if I'm applying any filter, I won't be able to see the effect of that specific filter onto the specific table that I'm passing as a parameter onto that all function, right? Just because there is no effect of any filter onto the table that you are passing as a parameter over here, that's why you can refer your all function as a filter remover, right? So it's not exactly too much difficult when we will be going forward with the practical implementation of it, you will be able to understand it more clearly, right? So in simple words, you can say that all function will be helping you out to return all of the rows that are present in a table or all of the values that are present in a column, and it ignores any filters that you have already applied. So filter like this, that is category name. So all of these filters will be ignored as soon as you are going to pass a specific table in your all function. And definitely it won't be returning a single value for you, just because what exactly we are applying the all function on is a specific column or a specific table. So that's why this all function used to work with the whole table or with respect to the whole column. So that's why it won't be able to return you a single value, but it will be returning the value that is completely dependent upon all of the rows that is present in your table that you are passing as an argument over here, right? So this is something you can get from your all function, right? And now let us look forward with the implementation of it, with the practical implementation, so that we'll get to know that what exactly do we mean when we are saying that all function is helping us out to get to have all of the rows. And I will be showing you the implementation of it in such a way such that you will get to know that why exactly all function is too much important for us, right? So let us create our first measurement, and that is giving us the insight about all of the orders that we had, right? So we already have discussed about this thing that is the total orders, right? So total orders, that was giving us the value that you can see over here itself, that is giving us the value of the distinct count. We have just calculated it in the specific video itself so that it will be more clear to you. So this total orders was giving us the insight about that what is the distinct order ID that is there, or order number that is there, and that is giving me the insight about that what is the total number of orders the company had within these 3 years, right? Distinct orders. So now if I want to simply go forward with this total orders only, and I don't want any filter to be applied with respect to the specific value that I'm getting, that is 25,164. So I'm not exactly interested that filters to be applied over here with respect to my total orders. So that's why I can show you that what exactly I can do from my side is that I can simply click on this table measure. I can go forward with my new measure. Just because it is a kind of aggregate function itself, this all function as well, just because it is working upon all of the rows. That's why I will be creating a new measure over here. And let me show you the all orders. And let me show you that how exactly the filter is not getting applied. So inside my calculate, as I was telling you, that calculate function will now be behaving as a kind of container function for us. So into this calculate function only, I will be passing my all function as a kind of subset function, right? So now I want to calculate the total orders. That is a distinct count of all of the orders. And I don't want any filter to be applied on my sales data table, right? So what exactly you're calculating at this point is that you are calculating your total orders, but you don't want that any filter should be applied from the sales data table, right? Or what exactly you're getting is the total number of values. What exactly you're getting is the total number of rows that are present in your sales data table, right? With respect to the total orders you were getting. Let me show it to you practically so that you will get to know what exactly we are mentioning. All right. Okay, first of all, there is no need to convert it into complete uppercase. Okay, let me now show you what do I mean by this. Let us plot these values. So total orders, you can see that with respect to total orders, the filters are getting applied on accessories, on bikes, and on clothing. And then you are able to see the total value. But if I'm simply plotting my all orders over here, then one thing you can see over here that now there is no filter that is getting applied, right? So you are trying to calculate the total orders again, but now any filter that you are applying, like for example, over here, I'm applying the filter as the category name. But with respect to category name, no filter is getting applied on my all orders. And I'm able to return the same number of rows that are present in my column or with respect to the total number of rows which I'm getting with respect to my total orders, right? So total orders was having the total number of rows as 25,164, and that is something I'm able to return when I'm using this all function, right? So this insight you can get. So the major funda of applying the all orders function is that, or the major funda of applying the all function is that you won't be able to see any effect of the filter that you are applying onto that specific measurement or onto that specific table, right? That is what the major funda of all function is. Okay, so let us go forward with one more practical implementation, and with this implementation, you will get to know that why exactly all function is too much important for us. So I have just shown you that the filter will be getting applied with respect to total orders, right? But the filter is not getting applied with respect to all orders. So for example, if I'm interested in calculating the percentage of total orders, right? What is the percentage of total orders that is coming from the accessories, from bikes and clothing? Then how exactly we'll be able to calculate it? As soon as I'm going to divide this specific total orders with respect to my sum of these three values, then I will be able to see the filter getting applied on that sum as well, right? As if I'm not exactly going forward with the all function, then you will be able to see the filter getting applied onto your denominator as well. And that's why you won't be able to see a proper percentage of total orders if you're not exactly applying this all function over here. Or what exactly I mean over here is that if you don't want your denominator to be getting altered because of the filter you are applying, then you should go forward with this all function. So you should apply the all function on your denominator so that you can make sure about this thing that your denominator won't be getting affected because of the filter you are applying over here, right? So let us see the practical implementation of it and let us see that what do I mean by calculating the total percentage of orders, right? So into my table measure, let me create a new measure over here. So I'm interested in calculating the percentage of orders. So the numerator will be getting affected because of the filter. That's total orders will be getting affected because of filters. But the denominator won't be getting affected of filters just because I'm applying all function onto it. So let me calculate the percentage of total of all orders. Or total orders, you can also call it as, that is completely fine. And now you can divide, wherein on your numerator, what exactly you will be keeping over here is the total orders, right? Total orders that is coming from each and every single category name. And just because your denominator you don't want to get altered because of the filter, that's why you will be going forward with applying all function on your denominator. And this all function, or just because you have already calculated the all orders, right, which was being calculated by applying the all function itself, so there is no such requirement to go forward with again calculating this total this all orders, right? So let me just pass on the denominators as all orders itself. All right. So this all orders was being calculated in a way wherein it is not getting altered because of the filter that I'm applying. So this value would gonna remain constant, but the numerator will be getting affected because of the filter, because on the numerator we haven't applied the all function. And that's why we will be able to see a proper percentage of all of the orders, right? So let us see what we are getting exactly. All right, so percentage of all orders, let me add it into my values. Okay, let us convert it into a percentage format. And now you're absolutely able to see that what is the percentage of orders is there in my accessories, in my bikes, and in my clothing, right? So again, that total summation of percentage is not coming out to be 100, but we have discussed about this thing in the previous video itself, that why this summation doesn't really come out to be the equal to that of the total percentage, right? So this visual, by this visual, what I exactly mean to say is that out of the 100 percentage of total orders we are having, or all orders we are having, in 55.35 percent of orders we are having are bikes as one of the product, right? In a similar way, around in 67% of orders we have seen our accessories to be there, and in a similar way, in around 28% of orders I've seen my clothing to be also there into my all orders, right? So this insight you can get from your percentage of all orders, right? And definitely you have to calculate these important insights, and definitely making the use of all function is going to be an important scenario over here. Just because you don't want your denominator to be getting altered because of the filter that you are applying, right? So that's why you can see that why exactly all function is coming out to be an important function for us whenever we are going forward with calculating such important measurements, right? So this is going to be an important example of looking into that why we are going forward with this all function, and we can also come up with one more measurement. Let us calculate that as well. So I'm interested in calculating my overall average price, right? So that I can show you that how exactly the overall average price is getting altered because of the overall average price, how exactly it is different from our average retail price. So already in our table measure itself, we have calculated our average retail price, right? Yeah. If I'm just dragging my average retail price over here into this visual, then you will be able to get to see that what is the average retail price coming over here. And yeah, one more thing I would like to show it to you over here, that we are keeping our average retail price in rupees. That is not something we should do, right? Just because it is in dollars. So that's why you should change the format of it, and you should keep it in into dollars itself instead of keeping it in rupees. All right. So now you are able to see the average retail price, and now let me show it to you the overall average retail price, and we will be simply differentiating that overall average retail price with respect to your average retail price, that how exactly the values are different from each other. So now with respect to my table measure, I'm going to create my new measure over here. So the measure I'm creating is going to be my overall average price, and now I'm going to calculate the average retail price when no filter is being applied onto my product lookup table, right? So you want to calculate your average retail price, that is this price, when no filter is being applied onto your product lookup, so that you will get to know that what is the average overall average price you're getting. Let us see this at what exactly we're getting over here, and let us compare this overall average price with respect to your average retail price, right? So once we are done with calculating this overall average price, let me drag it and drop it over here. And you are able to see the similar value, right? You are able to see the similar value that you're getting with respect to your overall average price. That is $714. And you can see that with respect to components. With respect to components, the average retail price is coming out to be a bit closer to the overall average price when the filter is not getting applied, right? But with respect to the bikes, definitely the average retail price might come out to be greater as compared to our overall average prices, because bikes are definitely going to have a great price as compared to it, right? But that was the important insight that we wanted to show you. And by the example of this percentage of total orders, you will get to know that why exactly we don't want some of the values to be getting altered, or we don't want some of the columns to be getting altered because of the filter that we are applying. Just because we have to come up with these important measurements like the percentage of total orders, right? So with this example, you might would have got the idea that what exactly is our all function as our filter remover function that we are going to make the use of. And now we are going to relate this all function with respect to the new functions also that we are going to discuss about in our upcoming videos. That is the filter function. So in our upcoming videos, we will be discussing about the filter function, and that would be all regarding the all function, and let us meet in the next video with the assignment with respect to our all function and the calculate function that we were discussing in the previous videos. So that would be all, and thank you. All right, guys, so let us get started with our sixth assignment, and that would be regarding the calculate and all function that we have discussed. So let us get into each and every single key objective that is mentioned over here. So first of all, we have to create a new measure with the name as all returns to calculate the total number of returns, and regardless of the filter context. So again, you have to go forward with calculating. You have to make the use of this calculate function. Into that function, you have to pass the expression, which is giving us the idea about the total returns that we have already discussed about, right? So in the previous video itself, we were looking into that total returns, what exactly it was coming out. And then that you have to pass to the first parameter, and then as the second parameter, you will be making the use of the all function. In that all function, you will be simply going forward with all of the rows with respect to the returns table, so that no filter is getting applied into your all returns, right? So this is something you can do from your side for solving the first objective, and let us move forward with the second objective, wherein we have to create the new measure with the name as percentage of all returns that divide total returns by all returns. So we have looked into this percentage of all returns kind of example in the previous video itself. So that's why it won't be a bit difficult for you to actually calculate it. And once you will be solving the second key objective, again, you will get to know the importance of all function, right? Why exactly this all function is being preferred for coming up with some important calculations, right? So that is going to be our second key objective, and in our third key objective, we have to create a matrix to show the percentage of all return as the values and by the product category's name. So again, this example we have already seen in the previous video itself, that with respect to the category name, what exactly we were getting as the percentage of total orders. And then you have to make some important conclusions, that which category is accounting for the largest percentage of returns and which is accounting for the smallest percentage of returns. Right, so it won't be a bit difficult for you. We have discussed about the example like this in the previous video itself, so that's why definitely you can try it out from your side, and we will discuss about the solution of these key objectives in the next video. So that would be all in this video, and let us meet in the next video with the solution of these key objectives, right? So thank you. All right, guys, so let us get into the solution of each and every single key objective. So the first key objective is asking us to create a new measure with the name as all returns, and we have to calculate the total number of returns regardless of the filter context, right? So just like the last time, I have calculated all orders in a similar way. I will be showing it to you, the practical implementation of creating all returns. Click on table measure, click on new measure. You will be able to create your new measurement as all returns. First of all, let us name it. All right, and now I'm going to make the use of the calculate function. And by using calculate function, I have to calculate the total number of total number of return rate, right? Or total returns. So I have to calculate the total returns when no filter is being applied on my returns data table, right? So that's exactly how you will be able to come up with the total all returns. Let us evaluate it and let us see what to our all returns. And the third key objective is asking us for showing us the matrix, or to actually create a matrix to show the percentage of all return values by the product category name, right? But the thing is that, first of all, let us start from this point itself with creating a new matrix, and in the rows itself, we can pass on the category name, and we can pass on the all returns value. So to get to see that what exactly this all returns is showing us at this point, right? So let me create my new matrix over here. So this matrix option you will get to see over here. So there is a table option, there is a matrix option. So in the matrix option, you will get to see this blue kind of boxes that is associated, right? So that's exactly how you will be able to differentiate between the table and the matrix. So let us go forward with this matrix. We have to show in the row section, that is the category name from the product lookup table. From the product categories table, right? From product categories lookup, we have to show the category name, and let us see that what exactly is the value we're getting for all returns. All right, so all returns is coming out to be as 1809, right? That is all, that is going to be the total number of values we are going to have into my returns table. Just because no filter is being applied with respect to my returns table, and that's why we are able to see an appropriate value, that is 1809. And even if I'm applying a filter like category name over here, I'm not able to see any change or any effect on the all returns value. Right, so this is the first thing you can do from your side. Let us look upon our second key objective, that we have to calculate the percentage of all returns that divide total returns by all returns, right? What exactly was our total returns? First of all, look upon that. So total returns was coming out to be as count of the return quantity, right? Okay, we are done with this total returns, and now we have to divide this total returns with respect to our all returns, such that we can calculate the percentage of all returns. Again, let me revise this thing that as soon as you're going to divide this total returns as the numerator with respect to your all returns as the denominator, you will get to see the filter getting applied on total returns, but not on all returns. Just because all returns is being evaluated by applying the all function, right? But total returns is having no all function associated with it. So that's why the filter will be creating an effect on this specific measurement, but not on this specific measurement. That is all returns. Right. So let us move forward with our next key objective, and that is to calculate the percentage of total returns, right? So let me create my new measure over here. We actually came up with a lot number of measurements, right? Like over here itself, you can see that how many number of measurements we are having. Okay, so let me go forward with creating my percentage of total returns. All right, and let me calculate, or in this specific case, just because we have to calculate the percentage, so we can divide our numerator. This numerator is going to be the total returns in the numerator, and then my denominator is going to be all returns, right? And now this will be giving me the total percentage of all returns. Every time you have to make sure one thing from your side, that you should represent this in percentage itself. So the format, you have to keep it as percentage by clicking over here. Now once you are able to look into this, now let me just drag it and drop it over here, and we can simply remove this all returns, right? There is no point of that. So the conclusion that we can come from our side is that the maximum returns we are getting is from accessories, and the minimum returns we are getting from clothing. As most of the time people don't really return their clothes, right? But accessories is something, if they are not exactly figuring out as that much as important, so they used to return it, right? So that's why this conclusion you can come up from this matrix itself, that the maximum percentage return you are getting from accessories, and the minimum is coming from clothing, right? So I think that was all regarding the three key objectives. That was something they were asking to us. So largest is from accessories, smallest is from clothing. We have solved our key objectives second as well and first as well, right? So it was a pretty basic one. You can definitely try it out from your side as well. And that would be all in the solution walkthrough of our sixth assignment. And let us meet in the next video with discussing about the filter function. So thank you.